Okay, this is Drew Decker with National Geospatial Program, and welcome to the Hydro Community Call. It's 2 minutes after the hour, so I think it's okay to get started here. Before we get going, please note that we will be recording the session. I believe the recording has already started. Thank you, Alex, for that. The resulting video will be posted for access within several days, and we'll provide a notice and link to the group. So welcome to the April call. I'll be assisting with today's call. Alex Jonasy with the NGP Topographic Data Services Group is also assisting with the call today. And we're going to go ahead and get started in just a moment with today's topic, which is the 3D HP transition update to be presented by the USGS Hydrography program. And typically, before we get started, I ask if the hydro leads have any announcements to make or any discussion from them. But since they're going to be presenting today, I think we can probably go ahead and get started. And I see Steve Aichele, Buto, you're on the call. I don't know if Sylvia is on, but how would you like to take it from here with the update for 3DHP?
How about we just put a presentation up and get going?
Okay, sounds great.
All right.
Please.
Okay. There you go. Hopefully you're seeing a presentation.
Yes, we see it. Mm-hmm.
Okay, very good. I'm I probably recognize my voice, but I'm Steve Aichele. I'm the planning management lead for the hydrography program at USGS. I'll be assisted here by Buto, a couple slides down the road. She's our data acquisition lead for hydrography. And the intent here is really just to provide a update on where we are sort of halfway into this transition year and where we think we're going to end up at the end of the year. So those of you that are regular participants on this call will have seen some of these slides before. But I do want to include, again, I want to include them for a little bit of context on where we are and where we're going. And so that's the agenda, right? What we're up to. There have been a few changes and course corrections as we've been going, and then a little bit of a preview on where we're going. Those of you that watch me do these presentations, I like to use this slide just to set some context for what it is we're about and why we're doing this. Obviously, 1884 maps were the only way of conveying geospatial data. Today, we're obviously more about data than the maps themselves, but I think the basic sentiment is still there, and I think still a fairly motivating principle for the geospatial program. We've talked about this slide before as well, but really the advent of 3DEP and really direct measurement of the landscape again takes us back to our roots of surveying the landscape and conveying that data, right? So we are back in the business of going out and collecting data and providing that data back to citizens, scientists, land managers, the public, as maps in some cases, but as data as well that you can roll your own applications from. So this is a significant reversal from where we have been from the late 20th century up to present, at least with hydrography, where most of that data has been derived from that old cartographic data source. So just a 3DEP status slide. This is as of earlier this month, and we are rapidly filling in this map. Some of these are actually recovered, recollects in a few areas. So most of the eastern U.S. Is looking really good. A few patches in the west that are still need to be acquired, but rapidly approaching completion on 3DEP. And that high quality source data really enables us to move in moving in a new direction towards reintegrating these data sources. So that's 3DEP up on the upper left there as we approach, actually a little bit over 90% with that graphic that I showed. And then again, regular participants here will be familiar with the NHD plus high res. And that actually in many ways demonstrated we kind of pushed that existing hydrography data as far as it could go. We're enforcing that old hydrography data on the new 3DEP data, burning it in some pretty severe ways to enforce flow. But it also demonstrated the value of the catchment concept as a framework for modeling, as a way of linking the landscape, the watershed, to the channels and to the water bodies, to make sure that, to understand things like pollutant flows or water flows or effects of land use on water bodies. So where we're going in the next generation here is really to leverage that 3DEP data for hydrography, and that's the 3D hydrography program, but also to launch a next generation 3D elevation program with frankly higher quality data and new refresh cycles. And so that'll be rolling out later this year. And this is all with the goal of eventually getting to a fully integrated 3D topographic model that would include, obviously would include elevation and hydrography, but might well include other thematic data, things like land cover or structures or transportation, but perhaps other data we're also collecting, like geologic data, right, aquifer data, really provide a framework, a stack for the full context of topographic data. So our previous approaches to national hydrography were largely to take those blue lines and convert them into computer readable DLGs and then eventually NHD, and it resulted in a very comprehensive, really the only comprehensive nationwide data set of hydrography, and then of course the watershed boundary data set as well, leveraged for a lot of applications. Unfortunately, we haven't had the resources to do proper maintenance on that data. And so stewardship has been the path, and many stewards have been active at various points over the years. But a lot of the data also hasn't been touched. Probably upwards of half of that data in the current NHD is still based on the geometry from the old topographic maps. And so that causes some challenges in terms of understanding what you're getting as a consumer, right? So if one region, one state, one area has done a very thorough job of upgrading their data, and other states, regions, across the state line have not, this makes interpretation very difficult, particularly for anything that wants to cross that state, any kind of application that crosses that state line. And so this consistency issue is a significant issue that we hear quite a bit about from many of our users. We also have a really fundamental problem that the data just doesn't align very well with the 3DEP data, which is, at some level, is actually just a little bit embarrassing. So we need to do better than that. And this sort of gives you that idea, again, that plus or minus 40 feet on the blue lines was really quite good in the middle 20th century. But compared to 1 meter pixels from 3DEP, you start to see some of the shortcomings in that data. And so,
Steve,
yeah,
Steve, this is Drew. Just want to interrupt. We have a hand up here, Matt O'Donnell. Is there a question?
Okay.
I'm sorry, that was a mistake on my part. I'm sorry.
Okay, no trouble at all. Okay, thanks.
Just stretching. Okay. All right. So in designing the 3D hydrography program, we took a fairly familiar path. This is the same path we've taken with NIA with NEA to build 3DEP, the National Enhanced Elevation Assessment to build the 3D elevation program. Back in 2016, we did the hydrography requirements and benefits study, documenting all the user applications and all the benefits that would accrue from improved hydrography data. We also realized pretty quickly thereafter that that we really didn't have the infrastructure, even sort of the conceptual infrastructure, to build the data that needed to be built. The contracting infrastructure, for example, wasn't there. We didn't have the capacity, the ability to inspect data rigorously for, that had been contracted. And so we needed to take a few years to do some pilot projects and develop a better understanding of some of the things that would be necessary to launch a national program. And so that went through 2016, 2020, give or take. And then this is when Becky was in my position. We developed a national program recommendation and a call for action, and that text is available on the website under 3DHP. It will be available in print eventually. And so, in a lot of ways, this is a new start for national hydrography. This is the first systematic remapping of the nation's hydrography, wall to wall, since that original 24K mapping program in the middle of the 20th century. So this is a break from where we had been. Some of the goals for the program, in addition to the relatively straightforward one, or relatively simple to understand at least, goal of aligning vertically, horizontally, and temporally with the elevation data, we want to replace that older inconsistent data with a consistent national product, and leverage some of the governance practices that we've developed from 3DEP in terms of broad agency announcement as an acquisition strategy and a partnership strategy with states, working through the private sector through the GPSC contract, working with rigorous specifications and a rigorous data validation process to ensure the quality of the data that's going in. And then this one in bold, bold because it's actually important, right? Is really to build the system and the data structures for hydrologic applications, as opposed to hydrographic or cartographic applications, right? We're not just trying to show where the water is, we're trying to understand where the water is and build both the geometry that shows where the water is, but also the tabular relationships, the database connectivity relationships to allow better modeling applications, better routing applications to be leveraged against that data. And then finally build in the pieces that we will need, at least, to be able to do a better accounting of the full hydrologic cycle, not just surface water, but transport through groundwater, working with Fish and Wildlife Service to incorporate wetlands data in, working to bring in representations of urban hydrography, stormwater systems, and then also bring in interoperability with sort of ancillary layers that are commonly used to explain hydrologic processes, things like superficial geology, soils, land cover, that sort of thing. And then on the technical side, this is where things got particularly challenging. Up on the left, you'll see the National Hydrography data model, all 170 or so F codes. Over on the right is the WBD data model. Down in the lower section is the National Hydrography Dataset Plus data model. And collectively, these represent about 250 F codes, and there are about 13 different but interrelated tools that we use to maintain these things. And at this point, all of those tools except that NHD Plus HR build tool are based on Esri desktop technology, which is expiring. But one of the challenges here is that these data sets also represent a lot of overlapping content. And so that makes keeping these things synchronized and making them all work together relatively messy. So from a technical standpoint, we had a couple goals. One was really just to radically simplify this data set. We are carrying way too much, particularly cartographic information in here, rocks and levees and swimming pools and things that are not really hydrologic features. And it's makes the rest of this process relatively difficult. But we want to take advantage of the elevation data to make catchments that are really integral to the system, and use those catchments to build the hydrologic units rather than taking the hydrologic units, the water WBD, in as a separately delineated data set. That was, again, just even keeping the pour points synchronized was, sort of an ongoing challenge. And through this whole process, really, we want to simplify and accelerate the workflow to get new data represented in the finished product. At this point, using in the pre-existing system, if a change was made in the NHD, the refresh cycle is about 5 years to get that out in the NHD plus high res, and that's just not acceptable in this day and age. But that's a symptom of the complexity of the systems we built and the network that's out there. So going forward, where we want to go with this is to work with the OGC's high features data model. We'll have a little bit more about that here in a second. But this is useful in that it supports international standards as directed by the Geospatial Data Act, but also supports interoperability with other agency activities, Canadian activities, and provides a somewhat simpler vocabulary for understanding these hydrologic features, rather than sort of maybe the conventional way that humans might interpret them. And so this is draft. Don't commit it to memory, or certainly don't build anything against it. But this is an example of what the data model might look like. And with this structure, we're going to represent about 95% of the feature content from the NHD, but we're going to do it with about 20 F codes instead of 250. I'm sorry, I know, actually, more specifically, we're going to represent about 95% of the feature content from the NHD, the NHD Plus, and the WBD, and we're going to do it with about 20 F codes, because there was so much either overlapping information across the data sets, or stuff that was really ancillary to the hydrology. I put this up. This is in some ways a simplified view of how data flows through the existing NHD system. And again, it's not a commitment to memory kind of thing, but there are lots of there are a lot of different interdependent processes here. And a lot of them are tied up with the external editing. That was a really great concept back in 20 or so years ago when we started with that. But each year, each security update cycle, that has gotten more and more challenging to maintain. Folks that were active a couple of years ago recall when FTP was suddenly verboten. And we ended up with, we had to make some quick changes to shift to working in Globus, which is okay, but somewhat less intuitive. But it was just symptomatic of really the complexity and the interdependencies involved in having check-ins and check-outs and that kind of external editing capability. Where we're going with this going forward is a much simpler workflow, and obviously this is again a simplified flow, but really relying on a standard input format, and that's the elevation derived hydrography schema. This is what's described on our specifications page. We can provide provide a sort of an empty data set of the graph schema for you to fill in. But it's a file format effectively, right? And standardizing on that format as something like sort of like a CSV file or a DBF file might have been in the past, allows us to have a set of validation tools that we run that are expecting a certain data format, and those validation tools can ensure the quality of the data going into the data set. That's a key concept that we have not done in the past, right? If somebody went to the effort to update the line work, we largely assumed that line work was better than what we had, and it was accepted. Going forward, data will, at least proper EDH data will have to be validated. We are having some discussions about having some provisional data for places where EDH processes may not be appropriate, or where there are other projects going on. And Sue may be able to speak to that later on the presentation. Then we have this big core thing that is a little bit vague, and actually intentionally vague, because this is where we address a different set of problems that we had incorporated in the NHD, and that was that there was only one thing, right? There was the whole NHD. And so when you wanted to edit the NHD, you got the whole NHD. When you wanted to use the NHD, you got the whole NHD. And year after year, by far the most common use of the NHD was people would get it, download it, strip out the things they needed, and go merrily on their way with just the things, just those things. And usually with branched or orphan data sets. So we want to be able to simplify that deliverable for users so that it more appropriately meets user needs, and that you don't have to deal with that whole mess of a data structure to create a huck map, for example. Similarly, that provides us with a lot of flexibility on how we manage that internal data structure. We have an obligation to provide an output product in these views, but how we handle that internal database, if we need to change something for data management purposes, we can do that without having to change this whole ecosystem, which was sort of where we were at before. Some of you may recall a few years ago we were tried for several years to get drainage way added as an F code. That took about 4 years from start to finish, and because it had to go all the way through this whole ecosystem. As a change, an important difference from where we had planned we are going to add the existing NHD high res into 3DHP as a sort of a one-time load. So that whatever feature content was there in the past, right, about 95% of that feature content will come forward into 3DHP, and we will replace that as better data comes available. We also have this scaffolding concept, which I actually probably could have removed, but this is the concept that, and you can think of it as roughly hydrologic unit structures, but this is the concept that allows us to patch in pieces of new data as we go along, and understand how those fit into the network. So populating 3DHP, again, we will migrate that 24K NHD to the 3DHP schema. It'll be a little bit limited because it's obviously 2D data. It's flat. It won't have catchments, but it will be there to provide linear reference and connectivity. And then we want to add, primarily from elevation-derived hydrography projects. These are actually derived from the 3DEP elevation data, and validate that data before it goes in the database, try to ensure its quality. But this allows us to provide all the best available data in one place, and we will replace the older data as newer data comes in. And these are all the documentation for these elevation drive hydrography projects is online. In terms of data improvement, again, we're doing all the geometric validation up front. So we expect to have substantially less editing required going forward. But there probably will be editing. Something will be wrong, something will change, something will need to be updated. And so we want to do that through a markup tool. This will be very similar to the markup tool we have today, but it will be based on 3D-HP. And those I guess maybe two important points here. One is USGS will take care of the editing, the actual changing of the lines, which means that the changes can come in through a broader range of users, right? So a fisheries biologist out in the field, or a forester, or a kayaker who notices that something is wrong in the data set can submit a markup through the markup app. We will vet that through the state stewards to make sure it's a legit change. But then USGS will make that change directly. And then we expect to have these markup tools online in FY24. Data distribution, we really want to push services rather than sort of download and run uses. Initially, we're going to have 3 views: or cartographic, map making view, linear referencing, addressing view to support the Internet of Water, and then a hydrologic units view, primarily for water census activities. And we want to be able to provide these through web feature services, which is another benefit of radically simplifying the data system. We tried over several times over a number of years to provide the NHD as a web feature service, and it just wasn't possible with the IT that was available at the time. Simplifying the data model, simplifying the database allows that to work. And then going forward, we will have annual static releases for particularly for science purposes. People need to be able to reference a particular version, a particular release of the data. I mentioned the Internet of Water. This is something where we're not necessarily driving it primarily, but we're supporting it. We are providing the linear referencing framework underneath the Internet of Water, and sort of like census data might provide the addressing framework for a variety of other applications. It's a very similar concept to where we see 3D-HP fitting into this system. And I think with that, I think you have the next slide, Sue.
I think I do. Thanks, Steve.
Yep.
So I'll just go over a few slides kind of highlighting data acquisition for this effort. And I think I first want to highlight the idea that this is a very different approach to data acquisition to what we have done in the past to build out the NHD, where because of the relatively heavy lift of a systematic remapping of the nation's surface waters, we kind of need to build partnerships and approach this in a different way. So we're starting with a model that is based on the 3-step data acquisition model, and we'll adapt and adjust as we go and we learn how things will work for 3D-HP. So this slide just kind of gives an overview of sort of the 2 streams of data acquisition that come together to form an annual and a long-term data acquisition plan for this data set. And on one side of the slide, you see sort of a federal-centric data acquisition effort that is managed largely through the 3D-HP working group, which is a federal working group really designed to have federal partnerships for data acquisition, as well as sort of technical discussions around the 3D-HP. And when we partner with our federal, our sister and brother federal agencies, we can do that sort of at will by entering into an interagency agreement with our federal partners, and then working to do data acquisitions through largely our USGS Geospatial Products and Services Contracts, or GIPSI. And then the other side of this data acquisition is our broad agency announcement process. And that is really a fair and equitable way to partner with non-federal entities. Next slide. And so a little more detail on this process. As I mentioned, it's our mechanism that we use to partner with non-federal entities in a fair and equitable way, where proposals are received and then they're evaluated and scored by a sort of a panel of subject matter experts who determine how the proposals fit in with our scoring criteria. BAA is open to federal agencies and to state and local governments, tribes, academic institutions, and the private sector. And the idea behind a broad agency announcement, of this partnering mechanism, is that our applicants are encouraged to build funding coalitions within their state, and in the case of 3DHP, across state lines, to pool resources and fund some portion of the project costs. And then 3DHP matching funds would be added to cover those remaining costs. And I mentioned the idea of cross-state funding coalitions, and that will be important, different from 3DEP, where data acquisition was allowed to follow political boundaries. We will be following hydrologic unit boundaries, and so those boundaries will cross state lines in many cases. So we have to be a little more creative about our funding coalitions in those cases for this type of data acquisition. Next slide. So in this new paradigm for data acquisition, as Steve mentioned, we are moving away from sort of the direct editing model that was used previously for the NHD, and moving into a mechanism where we primarily prefer to use our GIPSI, or Geospatial Products and Services Contracts, to do the data collection. And the GIPSI is a multiple award acquisition vehicle, where the firms who are selected to work on the GIPSI have been selected based on their qualifications to do this work, both 3DEP data acquisition and 3DHP, or elevation derived hydrography, for 3DHP, in addition to other geospatial data collection activities. And so the contracts on GIPSI include the acquisition, the processing, and quality assurance, and then those data are pushed through our data validation processes, as Steve had mentioned. And in this instance, the contracts for this work are all managed by USGS, by our commercial partnerships team. And then there's also, within the broad agency announcement, there's also other mechanisms that can be used. There will be an option for our state and local partners to manage their own acquisition contracts. That's through a financial assistance award, or more commonly called a cooperative agreement. And then there'll also be mechanisms for bringing in data that have been derived or created by other mechanisms and then contributed to the 3DHP. We're working through the process of what that would look like and how data validation will look like for contributed data. Next slide. And so we've started this effort in Alaska. The effort in Alaska has been funded by the USGS Alaska map modernization funds, as well as some partnerships with Bureau of Land Management and Fish and Wildlife Service. And this started in FY19 with some pilots where we contracted with GIPSI contractors to give them portions, I believe, of a Huck 8 in Alaska, to sort of test their processes and us to understand how to validate these data. And since then, we have collected over 230,000 square miles in Alaska that are either available, conflated into the NHD, or are in progress through the end of last year. And those are the dark blue areas that you see on this map. And in FY23, we have another about 78,000 square miles that are either planned or in progress. And those are the cyan colors. The cyan with the stripes means that it's planned. We've not awarded a contract, and the solid cyan means that those are in process. The contracts have been awarded. I will note, we often say that the elevation derived hydrography for 3DHP is based on 1 meter 3-depth data. In Alaska, that is actually a 5 meter based on the IFSAR digital terrain models, which were the standard for 3-depth for the baseline first generation of 3-depth. And we're also very pleased to say that we are doing some combined EDH and NWI collections in Alaska in collaboration with Fish and Wildlife Service. In some instances, the data collection is being managed, or the contract is being managed by our partners in Alaska from Fish and Wildlife, and in other instances, the contracts are being managed by us with Gypsy. And this is a nice example of sort of coordinating between these two interrelated data sets and learning how to potentially collect them together so we can be more interoperable, which is a goal for 3DHP. Next slide. So in the rest of US, both CONUS and the Hawaii and the island territories, we are moving forward with data acquisition. USGS received a modest allocation in FY23 for CONUS data acquisition. And I should have updated this slide. We are planning an arid landscape pilot. We'll update the group when we get that kind of pinned down so we can learn better how to do data acquisitions in arid landscapes. And NRCS has been one of our prime partners in moving forward in CONUS. And they are funding multiple data acquisitions this year in Pennsylvania, Iowa, Ohio, on the Georgia-South Carolina border, and in Nebraska. So we very much appreciate NRCS's support and help. They've also were instrumental in funding existing acquisitions in South Carolina and in Pennsylvania. We're also very pleased to be partnering with the Forest Service in the Pacific Northwest, where we have plans for 3HP being collected in blocks of contiguous Huck 10 and 12s over Oregon and Washington to assist them with work that they're doing for wildfire mitigation in those states. We're also looking at a small pilot funded by the USGS Water Mission Area, actually the Idaho Water Science Center, to do some work potentially in Oregon. And then we have many states that are moving forward with data acquisitions, either through Gypsy, through the Geospatial Products and Services contracts. In that case, Tennessee is doing a pilot in one Huck 10. And then we also have active state projects in Michigan, Missouri, Texas, Washington. And I probably need to talk to Jane Schaefer-Kramer about potentially putting a star in California. I think there's some exploratory work going on in California with Jane. So I think that's all I have, and it goes back to Steve.
Sure. So, yeah, this is a slide you've probably seen before, but this gives you a sense of, well, one, it gives you a sense there are only 2 of these blocks that aren't filled in for this year. And really, that's an indication we're all dancing as fast as we can to try to make this conversion happen. But it also definitely, you see the emphasis on the purple region there, which is the data acquisition section of the chart here, and that's an indication of we really are trying to push ahead with gathering new data to update the surface waters of the nation in a timely manner here. And then let's see, find the right button. There we go. This is the 3D NTM has been updated, but it used to be 3D HP rules. But it's very similar to 3DEP. It's an activity that USGS will manage. We'll handle the governance, we'll handle the contracting, the data validation. But we definitely want input from the community on these things. And then I really want to try to emphasize that lower right steering wheel, I suppose, helm, whatever. That where this really matters is in somebody actually using the data. You can make the best data set possible. But if it just sits on a shelf, if nobody uses it, it doesn't really matter. So we do want people to adopt the data and work with this data going forward. So where do we plan to be at the end of the fiscal year? Again, this is the end of April. We're going towards the end of September as the end of our fiscal year. We are still planning to have a static NHD available, and those the existing addressing tools, for example, will continue to work against that data for the foreseeable future. We do plan to have a static WBD available. There's a strong possibility there will be a subsequent update to the WBD at some point in the future. There's a number of things that have been sort of lingering issues that need to be corrected there. But in terms of sort of continuous update, that'll come to a halt this fiscal year. We will have NHD-based data available in the 3D-HP views for cartographic and linear referencing purposes. So those two views, we may or may not get that water census hydrologic unit view up this fiscal year. We'll see how that goes. That I'll note that shift to incorporate the NHD data into 3D-HP was a fairly significant shift and did sort of throw some of our other plans for the year. Maybe not quite all the way askew, but they juggled some things a little bit. So we will have the NHD data available in 3D-HP, and we will have one HU8 of EDH-based data available in those same services. That's really sort of a proof of concept that the tools exist, that it works. And then next fiscal year, we're kind of adding more of the validated data into the data set. We hope to have the BAA announced this fall, along with the 3DEP BAA. There are still a few administrative hurdles to clear on that, but we're cautiously optimistic we'll get there. And then we're planning to have new addressing tools up for 3D-HP in FY24 and markup tools available in FY24.
Okay, thank you very much. So, Steve, great presentation, very informative. Thank you, everybody, for watching today. We'll have the video out within a few days. We're just a minute over, almost perfectly on time here. We're all set. So thanks again for your time, and we'll see you on another call in about a month.